Okay, guys, today we're going to finish up with box plots. So we did minimum, maximum, median, and range yesterday. And today we're going to add on interquartile range. Okay, so this one adds on something that's a little bit more, but a little different. And I'll go over it on the next slide. Okay, so like always, we want to read the problem and all of our answer choices, and then identify what is being asked. Okay, and in this case, we're going to calculate range and/or interquartile range, whatever gets asked. Okay, so this one is not only going to ask for interquartile range, but it might mix in median or the symmetry or things like that. Okay, and then like all the other ones, identify which statement is true. Okay, so here interquartile range. So if we look at that word, it says quartile. It's like quarter. So that means I'm splitting the graph into 4 parts. So the graph is split into 4 parts based on the box and whiskers. Okay, so the graph, when we split it, this first part is the first quartile. Okay, the first quartile. Okay, from the beginning, from the minimum to the beginning of the box here. Okay, and then the second one, this right here, the second quartile is from the beginning of the box to the median. Okay, and then the third quartile is from the median to the end of the box. Okay, and then my fourth quartile is from the end of the box to the maximum. So if you see that, look at it's 1, 2, 3, 4. We split up into 4 parts. Okay. The interquartile range, when it says to ask for the interquartile range, it's the range of what the box is. Okay, so we're going to take off the whiskers and we're just going to do the range of the box. So I'm going to find whatever this number is right here and whatever this number is, and I'm going to subtract them. So the end of my third quartile and the end of the end of my first quartile. So wherever the box starts and wherever the box ends, we subtract those two, and that's my interquartile range. Okay. And then each part represents a quarter or 25% of the data. Okay, so when you're looking at this, it might say, what's the range of the third quartile? So if I want the third quartile, that would mean I go from the median to the end of the box and subtract those two numbers. Okay, so that's what it is. It's a little more complicated, but once you get it, it's really easy to find. Okay, so let's go on and do some examples. The box plots show data about the runs scored per game by 2 baseball teams. Which statement is best supported by the information in the box plots? The Bears' interquartile range is greater than the Wolves. So I want to look. Let's find the interquartile range for both teams. Okay, so that's just the box. So I'm going to look at the end of the box. That's 7 here. And the beginning of the box, that's 3 here. So 7 minus 3 would be 4. So my interquartile range for the Wolves is 4. For the Bears, it's from 6 to 3. So 6 minus 3 would give me 3. This says the Bears' range is greater than the Wolves. And that's not true because this is 4 and this is 3. The Wolves' range, so now we're just looking at the range, is equal to the Bears. So now let's look at the range. So the range goes from the maximum to the minimum. So 8. So we start at 8 on both of these. And then this one we end at 1 and this one we end at 0. So 8 minus 1, my total range would be 7 here, right? And then 8 minus 0, my total range would be 8. So those aren't the same. So it's not that one either. The Wolves' interquartile range is greater than the Bears' range. Wolves' interquartile, we already calculated that, is greater than the Bears'. 4 is bigger than 3, so it would be C. The Bears' range is greater than the Wolves'. Now, those are both correct. The Bears' range is greater than the Wolves'. These are both correct. Uh-oh. The Wolves' interquartile range is greater than the Bears' interquartile range. They're both correct. I don't know what to tell you. That's weird. Bears' interquartile range is greater. The Wolves' range is equal to the Bears. Yeah, this should probably say less. Okay? But as you see, that's why we go over these. The Bears' range is greater than the Wolves' range. Okay? On the test, I guarantee you only one of them would be correct. Okay? Let's see another one. The box plots give data on the price of various kinds of fish at two pet stores. Which statement is best supported by the information in the box plots? The median price is less at Swimmers than at Seven Seas. So median, remember, is that line in the box, is less at Swimmers than at Seven Seas. So that looks like it's true because Swimmers is median is lower than Seven Seas. Let's see. The price ranges at the two stores are equal. So this goes from 8 to 1. 8 minus 1 is 7. And this one goes from 8 to 2. 8 minus 2 is 6. So they're not equal, so it's not that one. The interquartile range at Seven Seas is greater than the range at Swimmers. So let's look at the interquartile range. The end of the box, that's 7. The beginning of the box, that's 4. 7 minus 4 is 3. Okay, and then the end of the box is 6. The beginning of the box is 3. 6 minus 3 is 3. So they're actually the same. The interquartile range is equal. So it wouldn't be one is greater than the other. The interquartile range at Seven Seas is greater than the interquartile range at Swimmers, and that's not true either. Oh, this is greater than the range at Swimmers. Nah, 3 isn't greater than 6. Okay. And those aren't true. So it is A. Okay. And that's all there is to it. You got to do a little bit of math on these, but it's not that hard. Like it's not that difficult. It's probably one of the easier ones once you know what to look at. Because all you got to do is maybe subtract 8 minus 1. Maybe sometimes you got to do 80 minus 68 like that, but usually these numbers are pretty low and they're not difficult numbers to subtract. Okay, so there's no setting up a proportion, there's no multiplying or dividing, except for when you're finding the mean and dot plots. For the most part, most of these are just looking at the graph and seeing which is bigger. Okay, and that's all we have. Oh, we got one more. Sorry, I almost missed a problem for you. Okay, so this is about employees at the wages of employees at two stores. Okay, so let's look. Sloan's data are more symmetrical. That looks pretty even. Okay, but so we'll put a dot there and we'll keep going. The third quartile, so this is what I was talking about. This is just looking for the third quartile of wages at the two stores is the same. So let's look. Third quartile is the last half of the box, the last part of the box. So we're going to do 17 minus 15. 17 minus 15 is 2, right? And then the last part of this box, 14 minus 13 is 1. So that's not true. The interquartile range is greater at Toby's. So let's see. Interquartile range, just the box, 17 minus 13, so that would be 4. And then here, 14 minus 11, that would be 3. So they're not is greater at Toby's. Nope, Toby's isn't greater. Okay, the median wage is greater at Toby's. So median, if it was greater at Toby's, it would be up here above it, but it's not. So it wasn't that one. So it is A. Sloan's data is more symmetrical. Okay, and now that is all I've got. Okay. Your assignment today is going to combine yesterday's and today's, kind of like this question. It has median in it, it has range, it has your interquartile stuff, it has symmetry, all of that kind of stuff. It combines it all together and it's on Boom Cards, okay? If you have any questions, you know how to get a hold of me, and I hope you guys have a great day. Thanks. Bye.